Yeah.
Hi everyone, welcome to this week's Scrum meeting. And I'm gonna recap what Professor Ryu said in last week's meeting. He told us to not implementing the random forest model and naive Bayes model because we already have enough work done. And also we don't need to comparison other evaluation metrics such as precision, recall, and F1 scores. However, we need to still work on the deep learning model. And I hope for the next weeks we can start working on a deep learning model. And for this week, I did some cross-validation implementation. So I used k-fold cross-validation to evaluate the model performance across different subsets of the data set. And I think this method will help us prevent overfitting and provide a more reliable assessment of the model effectiveness. And specifically, I'm starting with a five-fold validation with balancing computational efficiency and evaluation thoroughness. Yeah, that's all for my part. I will hand it to Qianying.
Thank you, Chenxi. For this week's update, here's a brief summary of my progress. Last week, I worked on building the k-nearest neighbors and random forest models. For KNN, I carefully selected the optimal value for k by testing different neighbor values and found that k equal to 14 provided the best accuracy of around 85%. I also completed the evaluation of the RF model, which I plan to further optimize. Both models were trained using the Cleveland heart disease dataset, and the performance metrics, including accuracy, precision, recall, and F1 score, were thoroughly examined to understand their effectiveness in heart disease prediction. And currently, I am focusing on improving the generalization of our models through cross-validation techniques. Cross-validation helps ensure that our models don't just perform well on the training data, but are also generalizable to unseen data. The goal is to implement k-fold cross-validation for both KNN and RF models, which will allow us to evaluate how the model performs across multiple subsets of the data. This should help identify any overfitting or underfitting issues and give us a more reliable measure of model performance. And my aim is to complete this cross-validation step by the next meeting, after which I will analyze the results to determine if further tuning is required for optimal accuracy and generalization. And that's where I stand for this week. Thank you.
Hello,
So,
everyone. So last week, I focused on building predictive models using decision tree and logical regression algorithm. I started by progressing the data, which involved handling missing value, scanning feature, and performing feature selection. After that, I trained both the decision tree and the logical regression models on the dataset. For evaluation, I compare the models using accuracy score and confusion metrics to understand how well each model performed in predicting heart disease outcome. The initial results show some promising accuracy, but there's still some room for improvement. Currently, I'm working on implement cross validation techniques to enhance model generalization. Cross-validation will allow me to evaluate the model more robustly by split the dataset into multiple floats, ensure that each data point is used for both training and testing. This approach will help in fine-tuning and selecting the best model configuration will minimize the overfittings. In particular, I'm using k-fold cross-validation, which will provide a more accurate assessment of how the models might perform on unseen data. So that's all for my this week.
Hi everyone. Last week our team has successfully reproduced the original heart disease prediction framework using the Cleveland heart disease data set. We have implemented machine learning models like logistic regression, k-nearest neighbors, and XGBoost, improving their performance through hyperparameter tuning and better data handling. For this week, I'm focusing on study how these improvements were made, particularly how missing data were handled and how hyperparameter tuning worked. I'm also learning about the deep learning models like CNN and DN that we plan to integrate next. My goal is to better understanding how these models can further improve our framework. So I'll be ready to contribute more in the next phase of our project for next week. That's for my part.
Okay, thank you, Jalen. Good evening, everyone. This week I continued building models using the Cleveland heart disease dataset. I focused on refining the KNN decision tree and most recently random forest, although it's optional as Professor suggested. My goal is to compare their performances and identify which model best handles the classification task. After building and testing each model, I found that the random forest model provided the most robust results, and it effectively captured complex patterns while maintaining accuracy. Now I'm shifting my focus to implementing cross-validation techniques to further validate these models. Specifically, I'm working on using k-fold cross-validation, which splits the data set into multiple folds, allowing me to train and test the model on different subsets. This will help ensure the models generalize well and are not just performing well on the training data. Additionally, I will be fine-tuning hyperparameters using this cross-validation process, particularly for random forest and some other models. By optimizing parameters such as the number of trees and tree depths, I aim to find the best configuration that reduces overfitting while enhancing model performance. This step is essential to making sure that our models are reliable and can be confidently used in our project. To wrap things up, this week's focus has been on validating and optimizing the models to guarantee their stability and reliability for future use. That's all for my part. Thank you, everyone.
Thank you. Good
Thank
job.
you. Thank you.
Thank you.
You all.
See you next week.
Okay, see you
See you
next
next
week.
week.
Bye bye.